All right, so my other video was getting a little long, so I just broke it up into two. For this one, for number 9, we're looking at our denominators, right? And even though this one doesn't look like it has a denominator, 2 actually does have a denominator of 1. And then this guy, I'm hoping you can see, is difference of squares, right? That should be jumping out to you at this point, since we've been doing it for, a decent amount of time. So if I'm looking for my LCD, let's list them. I got p minus 2. I got a 1, right? Multiplying by 1, right? My other one. And then this last one, okay? Difference of squares. If it's p squared minus 4, by difference of squares, that would be p plus 2, p minus 2, right? They're both perfect squares separated by subtraction, okay? So if I'm writing my LCD, I would write p plus 2. But this, right, is a, so let me change colors. This is a repeat because we already have p minus 2. So I would not rewrite that in my LCD. So my LCD is just p minus 2 times 1, which we don't really need to write because anything times 1 is just still itself, so it's still p minus 2, and then multiplied by p plus 2, right? So that's my LCD. That is what I'm going to try to make each of these denominators. Okay, I just rewrote my problem just to give myself more space. I'm trying to make each of the denominators my LCD. I'm trying to make each of my denominators this guy up here. So for the first one, I'm missing p plus 2, right? If I have p plus 2, then now I have my LCD. So in order to make it, hold true, I need to multiply the top by whatever I multiplied the bottom by. For the second fraction, I'm going to have to multiply by p minus 2, p plus 2, right? Because that's what I'm missing. I'm trying to get it to be this LCD. Whatever I do on the bottom, I have to do up top. And for the last one, if you notice, right, it's already the LCD, so I don't have to do anything with that 8. So now let's rewrite our problem. I have p squared plus 2p. All right, that's all over my LCD. Plus, right, if I FOIL this guy out, which I'm hoping, right, I mean, I could FOIL it out, and I guess I will, just for argument's sake, but we already know what this is going to be when we FOIL it, I'm hoping, right, because, sorry, I made a mistake, because we already know what it is when it's, before we factored it. So we already know it's going to be p squared minus 4, but just in case you were sitting there and completely lost, if we FOIL this back out, right, these guys would go away and be left with p squared minus 4. So some of you might have already known that that's what we're going to do. Hopefully you did, because again, we already knew, what p squared minus 4 was when we factored it. So I would just be now multiplying that by a 2, right? So it would just be 2 times p squared minus 4 here over my LCD. And then here, since it's already the LCD, we don't have to do anything with the 8. Okay. So now I'm going to, or hopefully you guys realize, right, it's the same LCD everywhere, which means I can just get rid of it. Oop, that's supposed to be an 8. All right, now I'm going to combine like terms. I got a 1p squared plus a 2p squared, which gives me 3p squared. I have a 2p and minus 8 equals 8, okay? Hopefully you see, oh, I got a quadratic, so let's try and set it equal to 0. Okay, So I have a quadratic set equal to 0, so now I'm going to factor. Fortunately, my a is not 1. So I have 3p squared plus 2p minus 16 equals 0. Let's factor this guy now. Okay, again, my a is not 1, right? My a is a 3, which means I have to do a times c that adds up to b. A times c that adds to b. Okay, and again, by doing a times c, I figured out the factors to break up positive 2 as. GCF here would be p, and I'd be left with 3p plus 8. GCF here would be negative 2, which would give me 3p plus 8. Okay, I rewrite with my GCFs, and then the 3p plus 8. What would give me 0, basically, in both these parentheses? Well, that's going to be p equals 2, and we might, we'll just solve a quick equation just to show you. Okay, I have those two p's. So what you just want to do is just go back and just check and make sure that it makes sense in your answer. Because, look, if I have p equals 2, if I put that into the original equation, what would I get? I would get 2 over 0 plus 2 equals 8 over 0, which doesn't make sense, right? It's undefined stuff. You can't put 2 back into the equation because it would give you a divide by 0 error. So then for the second one, fortunately, that's not going to give you any divide by 0 errors, right? So this is your only answer for that guy, all right? And I guess we should just double check, even though it's going to be ugly because of the fractions. 8 over 3 over negative 8 over 3 minus 2 plus 2 equals 8 over negative 8 over 3 squared minus 4 would give me negative 8 over 3 all over, let's slide this down, all over, if I was to make this a 3 by multiplying by 3, and multiply this by there we go. So that would give me negative 14 over 3 plus 2 equals 8 over 64 over 9 minus 4. So this is getting really annoying. If I do negative 8 over 3 divided by 14, negative 14 over 3, it's negative 8 over 3 times 3 over negative 14, which would give me 4 over 7. Okay, plus 2, and just to change it into common denominators, and then over here, oh boy, okay, to make this a 9, this would be a 63, so 64 minus 36 would give me 28, so I got 28 over 9 all over 8, so 8 divided by 28 over 9, 28 over 9 would give me 8 times 9 over 28, give me 4 over 14, 36 over 14, which would give me 18 over 7, which thankfully 18 over 7 does equal, right, 18 over 7, so that is my answer, all right, which I kind of assumed it was, but just want to go back and check that, yes, this was the only answer for that one. All right, last one for today. This is not as hard as the last one, but I did just want to go over it. If we're looking at something like number 5 on page 15, we're saying to ourselves, okay, let's look at the denominators. We need all the denominators the same, right? For some reason, I don't know why, but for variables, a lot of people always forget that that's technically like a whole number, right? So you put it over 1. So what's my LCD? I would want to try to make all the denominators. It would just be 1 times 1 times W, which is really just W. Okay, so I would multiply this by W on the bottom and on the top. And I would multiply this by W on the bottom and on the top, which would give me W squared equals 10W. Right, I didn't have to do anything to the 16 because I didn't do anything to the W. So now that they're all the same denominator, get rid of this guy. I'm just left with W squared plus 16 equals 10W. Uh-oh, I got a quadratic, which means let's set it equal to 0 by subtracting 10W on both sides. Let's change the color. So I'm left with W squared minus 10W plus 16 equals 0. Luckily, my A is 1, so what are my factors of C that add up to B? But since it's a negative 10, right, they both have to be negative. It's okay that they're both negative because 2 negatives multiply to a positive number, but add to a negative, so we're good. So I get W minus 8, W minus 2, which means W would equal 8 or W would equal 2. Let's just go back and check and make sure both of them work. For 8, does 8 plus 16 over 8 equal 10? Yes, it does, because that would be 8 plus 2. And then does 2, sorry, yes, that one works. And then does 2 plus 16 over 2 equal 10? Yes, it does, because that would be 2 plus 8 equals 10. So they both work, so that's good. All right, so you guys are just going to do 3 problems for today.